Our code now has the perfect structure in place to let us play around with animations freely. So it's time to learn about CGAffineTransform. This is a structure that represents a specific kind of transform we can apply to any UI view object or subclass. Unless you're into mathematics, affine transform can seem a bit like a black art, but Apple does provide some great helper functions to make it easier. There are functions to scale up a view, functions to rotate, functions to move, and functions to reset back to default. All these functions return a CGAffineTransform value you can put into a view's transform property to apply it. As we'll be doing this inside an animation block, the transform will automatically be animated. This illustrates one of the many powerful things of core animation. You tell it what you want to happen, and it calculates all the intermediary states automatically. Let's start with something simple. When we're at current animation value 0, we want to make the view 2 times its default size. So back in Xcode, I will find that window again, and here we have case 0. I'm going to say self.imageView.transform is a CGAffineTransform, and I'll use scalex y as its initializer. I'll do scalex2 and y2. So that makes a new affine transform and applies to the image view straight away with scalex of 2 and y of 2, which means twice its normal size. Now by default, UI kit animations have an ease in, ease out curve, which means the movement starts slow, accelerates, then slows down before reaching the end. I'll press Command R to build and run the code again. We should see pressing tap the first time will make it scale up neatly. There's our penguin, there's tap, I'll press tap, boom, up it goes. Now if we keep on tapping, again and again and again, nothing will happen. This is because the animation loops through all its values, then goes through 0 again, and eventually it'll hit this line of code running an affine transformation again. And it's already at 2 times the normal size, so that will do nothing at all. The next case of our current animation property will be 1, and we're going to use a special existing transform called .identity. This effectively clears out any predefined transform, resetting any changes that have been applied by modifying its transform property. So we'll say case 1 self.imageView.transform is .identity, the reset transform. With the second case in there now, hopefully if I press Command R, we can press the button more than once, see it scale up and then down again. So here's the first one, up it goes, and then down again. Beautiful. If you repeat again and again and again, it'll do nothing for a while. Eventually, it'll repeat again back to 0, and then animate down again. Notice the way the tap button disappears correctly, and then reappears once the animation finishes. Let's add some more cases. I'm going to say case 2, self.imageView.transform is a CGAffineTransform. And this time I'm going to use the translation X and Y initializer. So I'll say -256 and Y -256. So move 256 points to the left and up. And then for case 3, we're going to copy and paste this line here. Go back to being identity again. So it will scale up, scale down, move up and left, then move back to the center again. So let's press Command R, see how it looks. So up, down, move up and left, move back to the middle again. Fantastic. So these values here, as you've seen, translation X and Y are relative. They're deltas to the current position of the object. So subtract that from the current location of the penguin. We can also use CGAffineTransform to rotate views using its rotation angle initializer. This accepts one parameter, which is the amount in radians you want to rotate. Now there are 3 catches to this. First, make sure you provide the value in radians as a CG float. If you just do something like 1.0, it's okay, Swift will figure out that means a CG float. Second, core animation will always take the shortest route to make the animation work. So if your object is straight and you rotate 90 degrees, which is in radians half of pi, it'll rotate clockwise. But if your object is straight and you rotate to 270 degrees, that's pi plus half of pi, it'll rotate counterclockwise, create the smallest possible animation. And third, a consequence of the second catch is, if you try to rotate 360 degrees, i.e. pi times 2 radians, core animation will calculate that the shortest rotation is just don't move, because we're already there. The same goes for values over 360. For example, if you try and rotate 540 degrees, 1.5 full rotations, you'll end up with a rotation of just 180 degrees. With all that in mind, here are two more cases that show off rotation. We're going to add case 4, which is self.imageview.transform equals CGAffineTransform using rotation angle dot pi, 180 degrees. And for case 5, I will paste in my code from before. Go back to Identity again. I'll press Command R again. See how this thing looks. I press up and then down and then move and reset and rotate and reset. Beautiful. As well as animating transforms, Core Animation can animate many of the properties of your views. For example, it can animate the background color of the image view or the level of transparency. You can even change multiple things at once if you want something more complicated to happen. As an example, to make our view almost fade out, then fade back in again, while also changing its background color, we're going to modify its transparency with its alpha value, where 0 is invisible and 1 is fully visible. And also set its background color property, first to green, then to clear. So we'll add two new cases. We'll say case 6, self.imageview.alpha is 0.1, so almost invisible. Then self.imageview.background color is .green. And for case 7, we'll say self.imageview.alpha is back to being 1 again, and self.imageview.background color is .clear, so a transparent background color. And that completes all 7 possible cases. So let's just give it another try, see how it looks. So up, down, move up left, back to middle again, rotate, reset, and then fade out and go green, and fade back in again and go back to being clear. Perfect. But Core Animation isn't finished just yet. In fact, we've only scratched its surface in these tests, and there's much more it can do. To give you the briefest glimpse of its power, we're going to replace one line of code, this one up here. This one starts the animation block. I'll comment out that code and say instead UI view.animate with duration, and this time I'm going to type in as well spring. So animate spring. And the code completion will come down to one option here. Press enter to select it. And there are lots of parameters here with duration, delay and so forth. But you'll also see now using spring with damping and initial spring velocity. So let's try and use that. We'll say with duration 1, with delay 0, with spring dampening of 0.5, so quite springy, a spring velocity of 5. These are values I've tried out by myself, by the way. For options, I'll do open and close brackets again. And then we have our animations area here. So I'm going to go ahead and get rid of that last part and replace it with a comma, then animations. This takes the closure again, and the rest should be the same, like that. Now when I build and run the code, it'll have spring animations for all those things we made. So it'll overshoot, then undershoot and bounce around a little bit. So watch carefully, you'll see it scale up, bounce, down, a little bounce, move, overshoot slightly, move back. Beautiful. Then fade out and fade in again. So it went black slightly there because we overshot the color. Generally a bad idea. And with that, we're done.